Hi, in this video I'm going to practice system design interview with some mock requirements, mock assignment that represents some typical flow that can be asked during the interviews for fintech companies, for neobanks. And since I am here by my own, I will make some assumptions of what in real life scenario interviewer might answer for my specific queries to be able to mm, describe more of what needs to be done, what needs to be designed in the system. So here we have new card issuing flow. As you can see, we have 5 screens here. First one is the entry point of where user can enter first screen of the flow with the card selection, with the type of the card selection. Then user needs to enter information about his name and address. Then also on the same page, user will see autocomplete address suggestions to fill the fields in the address for the address. And the next page will be the confirmation of the order with previously entered information. And at this page, user can confirm the order, and afterwards, user can get back and see the status of the order. There are several questions that I want to ask to begin with about the whole flow. First of all, is to understand the outer scope and from the start to end what we need to focus on the current interview. So next I will have some assumptions of what would be answered in the real life. So let's assume that we are not covering here the authorization flow because it is not represented in the UI and it is not the focus of the interview. Then the payment for the card will be handled for us by the backend. We will not need to provide additional steps for purchase flow and invoicing user logic. And we are not in charge of manufacturing the card. We are relying on the backend to return to us the information about the current step of the delivery. Then it's good to focus on, good to narrow the field of our focus of where we need to what we need to prioritize. And as I can see from this flow, the most important step is the order confirmation. It's good to clarify what kind of scenarios, what kind of business scenarios we can have on the order confirmation if it is not displayed here, but we probably will have not only network or unrelated server errors here, but also some business exceptions where like insufficient funds or some limitations of how many cards can be ordered at once. So it's also good to discuss of what are the fallback scenarios, what we want to do here if we receive from the backend response that is not a happy flow. And also worth to mention that in this flow, I can see that we have here some the placing of the orders also needs to be consistent. We need to make sure that we are not double ordering, that we handling properly the poor network conditions. And just to clarify our network conditions, it's worth to also ask about the target audience for this specific feature of what we are going to cover here. Let's assume that we have scalable solution. We will need to support at least 1 million daily active users. We have read heavy backend, so we need to we need to minimize pressure on the backend and cache on device what we can, and that the localization that the markets, there will be a single market where we want to roll out this feature. So we can start by writing something. Let's start with out of scope, so we will not have the payments and authorization. Let's say that we only have token that will be passed for all of our requests. Then our out of scopes, the localization is out of scope. Also, for our functional requirements, to save some time, I will start documenting this to not forget about what we just discussed. So for functional requirements, we need to display card options, autocomplete address information. Here it's good to clarify of the our like compliances for the address. If we can use here third-party services like some SDKs from Google to populate this view, but since we are working in the bank flow, let's assume that we cannot rely on the third-party services. So then custom geo-suggestions, then consistent order placement. What else? So next, for the details page, show or like preview order, and place or like check order status. For the requirements, we need to clarify if we want to see updates of the current status in real time. And as I can see on the picture, and the flow itself is kind of last longing, I will assume that we will not need real-time information. We are okay to just using pull to refresh or some polling or push notification based approach here. We don't need to display like up-to-date information because it is not changing rapidly. So no real-time updates, no delivery updates. Then for the collections that we have here, we have different types of cards, and was to clarify that if it's a static collection, if it's and if it's not, and most likely it's not, and coming from the backend, we need to understand the behavior of this collection, of how transient it is, how frequently it changes on the backend side, and how many elements can be displayed here. And let's assume that in this current flow we will have a lot of items, that they are not changing very rapidly, and for the mutations on the client side, we are not allowing user to apply any filters or sorting, and we rely on the backend side. So we will need to support pagination for card options to be able to support a long list of the options. And since this is not frequently changing collection, we also will need to cache our cards, and geolocation, since we agreed that for our requirements we are having, let's say, as we discussed previously, 1 million daily active users, more than 1 million daily active users. We have read to write ratio of like 100 to 1, and for the latency, we also need to clarify of what our what are expectations for the backend geolocation suggestion responses for the confirm order. And let's assume that for the order confirmation we are having optimistic response, instantly returning that the order is placed, and we are not waiting for this process to complete on the API side. And for the delivery address suggestions, we will need to support rapid, like 300 milliseconds geo-suggestions, which means we will need to cache it in a way, and then for the delivery status, like instant order placement or error. And we will need to clarify also the our security, since we're working on the we need to make sure that we are not exposing any personal identifiable information, what kind of compliances we need to have here. And due to the time constraints of the interview, I would assume that we will not have some in-depth compliances. So we just will need to make sure that no personal identifiable information is exposed. And there is a specific scenario for the virtual cards in this flow, and it will alter the flow, so there is no need for address for virtual cards, and it will have to include some other Google services and adding the card locally. So we are putting it out of scope because in this flow we will focus on the physical card delivery. Also, we see here some images for some preview of the card, and for the images we will need content delivery network for card previews. Also, will put out of scope now the estimates for the delivery, and the cost will just be hard coded, let's say, like based on the country. We can assume how long it takes. So the localization also will not affect the currency standards, the fields of the address. We will focus only on one market for the current flow. And for the other out of scopes, to save some time, I would put here out of scope server driven UI. It is a potential here. We could have modify different pages, but it is too complex to cover in such a short interview. And then we also will not have A/B tests here and feature toggles. For our observability, there will be just some basic analytics, again with obfuscating some personal identifiable information. I think now we can start with the high level of the API requirements. What are we expecting from our backend? And I'll just put it down here. In this flow, since we don't need fast updates, we don't need real-time updates for our status, and we are not going to support some complex UIs here, and not server-driven UI. And we will, for the simplicity, we will just use REST API with HTTPS and we'll have backend for frontend set up for us with the single gateway to simplify our flow and not relying on multiple services to get the information for our application. So we will start gathering some of the requirements. So we begin with our card options endpoint. Here we'll have versioning for the backend for backward compatibility to make sure that we are not breaking some old clients, since mobile clients tend to update slowly, and usually there are a lot of clients that are out of date. So we'll have our endpoint with card catalog, and for parameters, I will omit here the authorization token. It will be sent with in all the requests, just to simplify our presentation of the our schema, our pseudo REST API schema. I will not include it in each request, and only contextual what we need for it. And since for the card catalog we are supporting many items, we will need to support pagination here. There are two types of pagination that we could utilize here. Since the card catalog is not changing rapidly, we could rely on the offset based pagination, but for the to be future proof, to avoid any problems in future when the card list is being updated or reordered on the back end, it is better to use cursor based pagination. So we'll need to have our cursor here, and we will also have headers for our HTTP caching with etag, with sketch policy for and time to leave, so expiration date, we can save it up to 1 day, and the card information. So each time when user open the choose card page, the second page, we are not going to request more information if the current information is already up to date. Also, I did not cover the more of the offline mode. Let's assume that we can get to the third page. Let's assume that we only can show the card types and not allow user to continue for the delivery address. Or let's support the delivery address as well, but autocomplete feature won't be available there in the offline mode, so we will not proceed to the order confirmation, because we cannot support this feature offline. Also, if user if the process will be killed somewhere in between, we we'll need to make sure that the order placing was in process, and for some reason the process was killed, the application was killed during the process, we need to make sure that we continue the process, that we retry to send the information, and to use some backoff exponential backoff policy to try several retries before falling back with the error. And getting back to our catalog, so from the backend in the happy flow scenario, we will receive our options, or let's say variants, it's a collection of the card objects. We can tell that the card itself will have some basic information and ID, name, description, and some price objects that can be free or having specific currency and appropriate way of delivering the value of the amount that needs to be paid, the price. And for the image, we will have scalable images. Since we are having a content delivery network, it will be our URL to CDN. I mean, like it will be an object where we will have some ways how to some URL to CDN and ways of how we can resize the image in a way that we don't use too much of the traffic and memory on the client side, and to save some battery and having some flexible approach of the different screens, different density of the screens, of how big of the picture needs to be shown for every card preview. Then what else do we need for the card option? Yeah, I think we can get to the next endpoint. Here we are going to cover our this is wrong. It's not here, it is there. And here we need to get the address suggestions. We will use something like get for suggestions. Then it doesn't make sense to support here HTTP cache because we will have to store it for the short period of time. Here we don't need to send any headers, any related headers to this specific endpoint. I would rather design it with some memory cache that will live for example, for an hour or so, and we don't want to expose addresses since it can include some personal identifiable information, and so we don't want to store it for a long time, and it is too complicated to handle in this specific interview flow. So let's, for simplicity, we will not cache it in on the HTTP, and we don't need pagination here. We only show a few responses, and for the query parameters, we will have our query, and we will mostly rely on the front end, on the client side debouncing mechanism to not request information from the backend too frequently, to not DDoS it, and only request after some basic validation and with some settle down period. And when we receive a response, there we are going to have some suggestions with the collection of addresses, and for the address object we will have some ID, country, ISO code, and some other related information to our address. And then for the here we should be fine to proceed to the next endpoint, and on it optionally we could do some validation of the address here, since we allow user to enter information manually, but let's simplify this flow and validate address information only on confirmation order step. So backend will return some specific error in identifying that there is something wrong with the address. So all the validation will be happening on the last confirmation step, and this is the most important step here. And here we will have our post request, since we are modifying information on the backend, since we are providing placing the order. We will have we can have it as the order, and here to cover our non-functional requirement, this pretty crucial requirement to have our consistency in our order placement. We are including here our idempotency key, so we need to support it on the both client and API side. So client will need to generate the key, and this key will be used to make sure that we are in sync with the backend, and we are not placing double orders. We can continue the same order, and if something happened on the client side, so placing it, pressing the button again will not trigger the new one, but will return the cached one. There is a Redis catch that can be used on the backend side to rapidly return it, and we can put it in the header, the idempotency key. So in this way, we will need to backend will not need to parse the payload of the not need to get any information of the request. First we'll just check what is the in the header, and we'll have this short circuit of cached response from the Redis, and we'll just return cached information and not go through the whole process of the order placement. And then we will provide as our payload, we will have information about our card, the selected card type, the name information, the address that can be our previous object here, but since we are allowing user to change the suggested address, we cannot use just the ID. We will need to validate the input. So it could be some custom object, but yeah, just to make sure that we are not only relying on the ID, because the address can be changed here. And yeah, there are like here we can focus more on the possible errors here. We can have some business error that will return error object, and we can define of what it can look like. The object can return the something like code, the message, and action. So could be predefined in our for our business requirements, several types of error that we are expecting from the backend side if user have insufficient funds, if we cannot place the order, just have the explain the reason why, and we don't want to hard code it on our end. We want to just support several actions, and action can be just show alert or fallback to the previous screen or some specific screen, and message can be just any string, and codes just predefined codes that can be used for logging or just having our standards. And then for the it was for the business error. Then for the network error, we for the network error, we are going to implement some retry logic, some as I previously mentioned, some backoff, exponential backoff policy. So we will have some logic of retrying it from background to make sure that we have up-to-date information about the order process that has been started, and we receive the appropriate result from the backend, so we don't have desynchronization in between client state and the backend. And in the positive case scenario, we are going to receive status, can reflect what we see on the later on the delivery status, or alternatively can be something like rejected, and we can have some message here if needed to explain of what happened here. I would better have status object that will include our type of the status, that will be either rejected or placed, and other types, and timestamp for it, and some message, let's say, that will be either shown on the history steps, or will be just returned as the rejection reason, for example. And then the last one we will have for our status, so we can have card order card order ID status. Yeah, in here we also will have something like the order ID. So we can fetch this information again when we need it, and it's going to be used here in the as a parameter, but order status, we can just to keep it clean, I will have it as query parameters in these brackets. So we will just send the order ID, and in the positive scenario we will receive our status object. Yeah, we can also have here history. It could be done in we can send it actually in one flow, in one object, just collection of statuses. Since we already have all the required information, we can sort it by the timestamp and display it in this way, or using some other field for sorting. So we can have like statuses, or let's just call it history, where we are receiving the collection of statuses to display here. And we are not going to get into details of the tracking shipment or customer support. Also, I didn't put it out of the scope, the edit address information on the review screen, but let's just assume that we fall back for the previous screen here and allow user to modify the information back here. So it's purely presentation layer functionality. And with that, we can get into the overall architecture, the diagram of our mobile app, and the just overall expectations what we have from our API. So it's our API gateways. We will not get into details here of what is going to be exactly on the how it's going to be implemented, but we'll assume that it is microservices for delivery status, for the cards information, for the addresses. So we can just cards, geo, and delivery. Then we will have some Redis cache here as well for our fast response on some cache information for the cards, for the returning the order status, for the maximum efficiency. There will be a Elasticsearch for our geo-suggestions, and yeah, this is going to be connected to our app, and yeah, I did not So for the application here, we could use different architectural approaches like MVP, MVI, or Viper, or Redux, something else. But I will use just MVVM, standard MVVM for with unidirectional data flow, just as our industry standard, and for the simplicity of presentation it on the diagram. It's also I will use some dependency injection with the Hilt DI, with some 3 layers of clean architecture with the data and domain and presentation layers, decoupled components of the system for beta testability, and dependency injection for injecting different implementation. I will split here our diagram in a few parts. There will be data layer, the domain layer, and presentation layer. And this part is our backend that is out of scope. This is our data layer. This is our domain layer, and this is the presentation. So since we are not expecting real-time updates on the last screen on the delivery status, and we also need to support here some push notifications service. It is separate to our API gateways, and we can use here Facebook Firebase cloud messaging, and we will register our client there using the SDK on the application side, and then provide the key to our backend to be able to access the app, to notify the app using push from Firebase. And for images, we'll have content delivery network that will be, it doesn't need to be connected, that will be used for our media downloading, and we are going to have a separate flow for it. We don't want to send binaries of the images in our REST API in our response from our main gateway. Regarding the architecture for the app, as I already said, we are doing MVVM. I will just create blocks of what are we going to have here. So on the view side, we are going to use, there could be multiple options to how to implement views, but since we are interviewing for the company that are having a standard of using XML with theming and with some UI kit in XML, so we're gonna use it here with some recycler views or recycler delegates custom recycler delegates for the views. It is not that needed. We don't have like such different items in our lists, but just worth to mention. And also with like something like pager free library, then we will have our view models, standard view models from the for the provided by Android system, and we will have view models representing each view. It can be for each screen, or in more sophisticated, in more complex scenario, we could have views corresponding to each specific view instead of the screen. So in this way we can support later on some system-driven, server-driven UI, and have more flexibility in terms of how we want to rearrange the screens and reuse existing functionality. And we will have some navigation in that we can use a navigation component or similar to allow navigation between screens. Then as a foundation for our application architecture, I will just mention that this is going to be powered by dependency injection with Hilt. And then in our domain layer we will have our use cases for each individual actions, and also separate for all the observables that will return our flows of information. I can go into detail later on, and we also want to mention that we will have model for our presentation will be UI state and like StateFlow of UI states. And since we are not strictly following MVI here, we will have some shared flow of our like actions. So in this way we will make sure that we are not duplicating the actions. And on the domain side we will have our entities that will represent this is our main business layer, and these entities are not connected to either data or presentation. It's unaware of the exact implementation for any other layers. So it's purely business entities we have here. For the data layer, we will have our DTOs that will be mapped to our entities using data mappers. And in the UI flow, in the presentation layer UI states, we will somehow use entities to represent it on the screen. So for the use cases, let's just set the directions of the flow here. And here we will have directions going in this direction. For here also in the domain layer, we will have our repository interfaces. This is our contracts of how we can manipulate this data in the data layer, and how we can access it from use cases while not knowing the exact implementation behind it. And the exact implementations, maybe we can just call it repositories. They'll be in the data layer, and they will have, from one side, it's going to be the remote sources with, since we are using REST API, it's going to be just retrofit with HTTP. We also here will have some interceptors for our authorization tokens, and to place our idempotency key in the header, and for repositories are also connected to some local database, and here in this specific scenario, we are not going to store any personally identifiable information. Database will be used only to store some persistent information, like our information about the cards. So we can just utilize room here, but yeah, in some other scenarios we could consider using more secure options instead. But here room should be fine. And then we will need to have some memory cache for the for our geolocation suggestions. I will just use something like data store to keep our suggestions, because we don't need to save it for longer than the session and dispose of it after we are done with the single process. It's probably should not be connected. Yeah, but it's just for simplicity I will keep it here. And then for our content delivery network, we are going to rely on some like third-party libraries, some SDKs we will delegate our image loading to something like Glide or other libraries, and they are here represented on the presentation layer, but we keep in mind that they have integrated memory management, and we need to properly configure the Glide to expire our cache at some point, to not store it indefinitely, and to make sure that we are not overusing the images that we store for a specific card. We can follow some contract that we, for example, can provide in the image objects that we receive for each card preview, to define on the strategy that we are going to use for caching here. And I'll just show that we are using it in our presentation. Then we can follow some specific flows here of how the information, how the data flows for each specific scenario. So for our first, to show the card catalog, I'll use another layer. And so we are, since we are agreed to have information about the cards stored in our database, and because we have not often changing data on the back end, so we can keep it for up to 1 day. And when we open the screen with the card options, we will from the view, using view model and appropriate use case, we will subscribe for the updates that are coming from the database for card options that we have stored in locally. If we don't have anything to show, we will have our UI state just showing some loading indicator. But then the repository, after returning the flow to the upper layers, we will also make our remote call with the provided information for HTTP caching. So if we never requested this information before, we will receive the cards information to our remote source in the repository. We will store it in database, and since we already subscribed on the view to database updates, then it will be presented on the view. Next time when we will request it from the remote source from our backend, we will simply not place the HTTP call if with the selected cache strategy. For example, if we have HTTP cache for 1 day, and the same day if we are trying to fetch the same information, we will simply not do any call, and we just return from HTTP cache that everything is already up to date. And then we just receive the same response that will not update information in the database, because it is not distinct change, it's already there. And then for the flow of the and for the offline mode, it is not different. The only difference is that we will somehow include in the UI state the information that we are currently offline, to indicate it somewhere on the screen, to make sure that user is aware of the network problems, or that there is no network at all. Now, at the same time, we are not blocking the flow, because if we have something to show, we will proceed through this step. And then for our information that we receive from the geo-suggestion, and we will need to have some debouncing logic on our view model, or in our use case where we will debounce everything what is provided in the field, in the input field. We wait for some time to settle, to wait until the user stops typing, and only then we will request information. So we, for example, having the use case of where we handle debouncing, then we we make sure that we don't trigger the remote on each request, but we can utilize some memory cache here, so we can quickly go through the information that we store in memory regarding the suggestions, and return it first, and only after some settle down time we can request the backend information. And We also can limit not requesting anything from the backend for short queries, less than 3 characters, for example. If user did not type many symbols, we just not triggering backend for no reason. We can define it in somewhere in our business logic of how we handle this specific case. Then we, for the catching, we will use some catching when receiving response from the remote. So the next time when we request the information about the suggestions, we are going to first return something from memory. It is almost instant. And for this requirement, we don't want to utilize database because it can be a bottleneck writing something on the disk when we have our non-functional requirement to support quick updates for the geolocation. And even if we are using debouncing mechanism here, we still want to return data as soon as possible. So we don't want to store we don't want to cache suggestion information in our database, and it also can expose some personally identifiable information there. So it also will put some requirements on how we store data and clearing the data after some time to avoid any exposure of the personal information. And for the confirmation order, we will have our retry logic. We'll have our idempotency key, where we generated in our preferably in the we trigger it in the domain, and if we check in the repository implementation if we already have key, some pending operation of the order. We will need to make sure that we are not doing the duplicate on our side. Then we also will provide this key as a header to the remote, to make sure that we don't have any desynchronization with the backend as well, and like that we are identifying appropriately the current intent to confirm the order, and we will just generate on the contextual on the input information some UUID from the Android, and store it for the time being to be able to retry or to distinguish specific action and do not repeat ourselves. And for the delivery, that's delivery status. I did not mention here how we utilize the we will use something like WorkManager and notification manager that will access. It is not in the data layer, it is in our infrastructure layer, but we will subscribe for updates in the on our delivery status. And if we receive something, we will access our repository using dependency injection, and we'll just update the state of our delivery in the database, and showing some UI, some notification that the status has been updated. So the next time when user will open the app, the status will already be displayed, and at the same time we will fetch information again to make sure that we are up to date. So since we agreed that we will not have real-time updates, we will not need to use WebSockets or system server side events here. We will just get request when user open the delivery status page and use information that is already stored in our database for quick showing the result. And for the retry logic of the confirmation order, we can utilize another WorkManager, and here I will put it separately, retry WorkManager. So if in the middle of the confirm order confirmation logic, the app will be killed by system or something else has happened, we will be able to invoke the retry from the background and not waiting for the for user to open the app or like just wait for the network condition. We will have our condition for the WorkManager to only work when the internet is connected. So if user abandoned, so if in our scenario, if during the order confirmation the network has been shut and or the app has been killed, we can continue the logic of the for the order confirmation. We can follow the state of it, and so to make sure that we will show the status and that we completed this process of placing the order, because when we started this idempotency action, and we need to make sure that we completed the state and we are in sync with what is there on the backend side. And yeah, just some to mention that we will have some basic analytics in the analytics in implementation on the data layer, and some logger interface that we can access from either presentation or domain to log our analytics. This is the wrong direction, but doesn't matter. And that's pretty much it. There could be some in-depth questions here, but overall it should reflect of how the system should work for this specific flow.